Our next example is going to look at a parabola that has x-intercepts at 4, right here, and at -6, over here, and has a maximum of 10. It's got a maximum, that must mean it opens down. The vertical stretch factor is going to be negative. This is telling us the coordinate of our vertex. It's telling us definitely the y-coordinate is 10, but to figure out the x, we're going to have to find the point halfway between these two x-intercepts. The vertex is at the half point between these two. I tend to just count and find my middle, so I can tell that there are 10 spaces in between 6 and 4. -6, 5, 4, 3, 2, 1, 1, 2, 3, 4. It would be 10 steps, so if I count 5 in from either side, I should be able to find my midpoint is at x equals -1. But there is a formula that some people seem to like, and that's to find the average. Find average of the x-intercepts. Alright, so that would be the average of -6 and 4 divided by 2, because you're taking an average of only 2. -6 plus 4 gives us -2 over 2. That gives us -1. Therefore, our vertex is going to be -1 and our maximum 10. And our equation of the axis of symmetry is x equals -1. Just by finding the average of the two x-intercepts, or by counting and finding the middle. Alright, so let's put that point in. Let's call it right there. This is -1, 10. Determine the equation of the parabola in x-intercept form. Now that I have the two x-intercepts, I can write y equals a, x plus 6, x minus 4, again being careful of sign. I have a point to substitute in. When I substitute in, this is my x, and it goes in both x's. This is my y. 10 equals a, -1 plus 6, -1 minus 4. I'm going to have to keep going here. We'll have to do b a little bit later. We have 10 equals a, 5, and -5. So we get a equals 10 over -25. Let's make this lowest terms, 2 over 5. So in x-intercept form, we have y equals -2 over 5, x plus 6, x minus 4. Part B wanted this in vertex form. One key thing to remember is no matter what form, the A is the same. No matter what form we're talking about, our vertical stretch factor is going to be the same. Again, in general, in vertex form, we have an equation y equals a, x minus h squared plus k. This means that we have our vertical stretch, -2 over 5, x plus 1 for my vertex, squared plus 10. So here we have vertex form of the equation, factored form of the equation. 2 out of the 3 ways of expressing a parabola. In the next chapter, we'll do the last one. All right, flip the page over. Last one. Let's see if we can determine the equation of the following parabolas in both x-intercept and in vertex form. So in x-intercept form, I'm looking for where it crosses the x-axis. I'm going to take a look and see if I can identify my vertical stretch. Again, from a picture, sometimes the stretch is nice and easy. If it follows our normal stretch pattern of 1, 3, 5, then the stretch factor is 1. You don't need to write anything. If it's something else, especially if it's a fraction, we probably need to do a little algebra to find out what a is. So from the vertex, I go over 1, up 1. Then I go over 1 and up 1, 2, 3. 1, 3, and then over 1 and up 1, 2, 3, 4, 5. Yep, my a is definitely 1 in this case. I know my a is positive 1 because it opens up, it's a happy face. This means that my x-intercept form of my parabola is y equals, you don't need to write the 1, x minus 2, x plus 4. To write this in vertex form, again, the a is going to be the same. I just need to look at my vertex. My vertex is -1. Nope, sorry, -3, -1. So y equals, again, don't need the 1, x plus 3 squared minus 1. Let's try it one more time. We have our x-intercepts. Great, so I know it's something like y equals something x plus 0, though I don't really need to write the 0, I'll probably make it simpler in a sec, x minus 6. I take a look from my vertex, I go over 1 and down, I don't know, like a half, and over 1 and down like, I don't know. Okay, I'm finding it hard to read this step pattern, so what I'm instead going to do is identify my vertex, because that's another key point that I can see very easily, although I could have gone with, is there any other point on this graph that seems nice? That one's not too bad. I'm looking for anywhere where the line of the parabola hits the very center of the crosshairs of my grid, so that I can read the coordinate with some accuracy. This is 3, 3. All right. So to find a, I'll just leave this as a for now, and I'm going to put in 3 equals a, 3 plus 0, 3 minus 6. So we get a equals 3 times -3. We get 3 equals -9a. Therefore, a is equal to -1/3. So we can get our two equations of our parabola. In vertex form, y equals -1/3 x, x minus 6. So there's our plus 0. I just chose to leave it out. Same way if we had a 1 in front of here, we would just kind of leave it out. It's not important. And in vertex form, y equals the same stretch factor, x minus 3 squared plus 3. I paused there because I was looking at the other side and I made a mistake on my last vertex form one. I hope you guys caught it. Really easy to do. This, it should be positive 3. This is -3. Sorry about that. This coordinate is to the right 3, so that's a plus 3, and a down 1, -1. In vertex form, that makes this negative. Sorry. Let's go back and make sure I've got these ones right. Yes, yes, 3, 3. This is a negative stretch factor, so I expect a parabola that opens down. It's a stretch factor between 0 and 1 that makes the parabola vertically compressed or squished or wide, whatever word you'd like to use. It's a nice wide parabola going this way. Let's do a little bit of a summary. We've compared two different types of forms. We've got vertex form which is y equals a, x minus h squared plus k. This gives us hk, our vertex, and the a gives the stretch and direction. We also have our x-intercept form or our factored form. This is written in the form y equals a, x minus r, x minus s. It doesn't immediately have the x squared that is so characteristic of vertex form, but as you know, if you were to expand to use binomial expansion or to FOIL these two, these two brackets, you would end up with x times x, making x squared. Same as we have an x squared here. Without that x squared, we're not talking about a parabola, we're talking about some other shape. This gives us our x-intercepts. Which are r and s. Sometimes these are called roots, sometimes they're called zeros. The a is the same. Gives us the stretch and the direction. Again, the a is always the same. The vertex can be read very easily out of vertex form. The x-intercepts can be read out of x-intercept form, or what I call factored form.